All right, now we'll discuss decimals and their placeholders. What does this place indicate? The first place to the left. It's a whole number, considered ones, right? And it's designated by 1.
Isn't that negative?
No.
Okay.
How about the second place? Tens. And it's represented by 10, right? Next place is?
100.
And over here we're going to have 100. So like if we had a 3 here, this would indicate this is 300. If it were 5, it would be 500. That's where they're getting that from. All right, 4, the number 4 here, what place is that going to be?
1,000.
And it's going to be indicated by 1,000. Next place?
10,000.
And the last one here.
100,000.
And here's okay, so that's not that bad. Then we go to the right side of the decimal. What do they call this place? Tenths. It's the same as this, except they put a TH at the end. And what is its numeric representation? 0.1. So if I had a 3 here, this would be 3/10. If I had a 5 here, it would be 5/10. What about this next place here? Hundredths. And it's represented by 0.01. So if this were a 0 and I only had a 2 here, well, how would we identify that? 200ths. What if we had a 1 and a 2 here? Then how would we represent it? How would we say it? If we only had this, decimal point in the 1 and 2, how would we say that numeral? 1200ths.
Oh.
So at least at the highest value would be the top. How about this one? Thousandths with the TH again, and it would be 0.001. So if these were zeros, this would be 3 thousandths. Does that make sense?
Mm-hmm.
And the next one is 10 thousandths. And it's represented by 0.0001. The last digit here is and it's going to be represented, let's see, 0. Yeah. And as you notice, as the further we go to the right, the smaller the number gets. Because the more zeros to the left, it's actually getting smaller. Now, the next thing I want to do is I want to go over how would we verbally say a number that we're seeing. Say you had this. How would we say that? 1200ths. All right. How about if I had this? First thing is identify what place it is. It's 1, 2, 3, 4, so it's right here. We're in 10,000s. What's the numeric value here?
5.
5 ten-thousandths. What if we had this? We still got the same amount of digits,
34
ten-thousandths, because we're still here. What happened if I changed it to this? Let's take this off, put the decimal right here.
34,000.
Yeah, we got 3 places here. That brings us to here. We're in the thousands, so it's 34 thousandths. Let's make it a little trickier. Oh no. Come on, it's not that bad. How would we say that?
5.
5. And is the decimal point, right?
3,000.
3 thousandths. How would you say this?
517 thousandths.
Say it again.
23 and 517 thousandths.
How about this?
23 and 7,000.
Yeah, 23 and 7 thousandths. Okay. Seems like you got a firm grip on that. Let's switch to this. Let's say we have 2 decimals. We're going to compare. We want to know which one's larger, which one's smaller. Similar to what we did in fractions. I find it's easier to write them vertically.
Is that a 2? 3, 1, 2. Yeah, that ounces.
Let's write them that way for those who don't know what it represents. I don't want to mention any names, Mariah. What we usually do is, let's look at the first digit. This is 4 and this is 4. So technically these 2 decimals are equal at this point here. Let's go to the next digit. Well, this is 3, this is 3. Technically, they're equal at this point. Go to the next term. Well, we got a 0 here and we got a 1 here. Since this one is larger than this is larger than that. So what you do is when you're comparing a decimal, you go start to the left and compare each digit at the same location. You want to make it a rule? We can make it a rule. Rule.
I need to write this kind of thing.
All right, so Mariah, since you have so much enthusiasm, tell me what the rule is.
Okay, I don't have enthusiasm.
I'm going to start you out. To compare.
Decimals.
Decimals.
Start to the left and compare to the right.
Start from the left. Let's say leftmost of the digit. All right, what's the rest, Mariah? We started from the left here.
Move to the right and see which number is bigger. I don't know.
Keep comparing as you move to the right.
Yeah.
Then it's just numerically. If the number's large, whatever, you keep comparing. You have the same thing, same thing. When you have a difference, whichever number is larger, that decimal's larger. Whichever one is smaller, that decimal's smaller.
On the left and what?
Leftmost digit?
Leftmost digit, so I'm saying go all the way to the left. Or you could say the digit furthest to the left. Leftmost, furthest to the left, same thing. Does that make sense? Let's do a couple more examples. All right, let me give you a chance to get this on in your notes.
Too bad. One of them is larger.
All right, let's do that. Let's change it. If this were a 6, we're going to compare it. We're going to go to the leftmost digit right here and start to compare. Well, this is larger than this. So you're done right there. It's when they're the same, you got to keep going to the right until you find a difference. Okay. Which one's larger, which one's smaller?
40.5.
Yeah, this one's larger, because we start all the way to the left, 4 is larger than 3, we know this is already larger. How about this one?
Same.
The one on the bottom is larger.
They're the same.
This one's larger?
They're even.
No.
They're
They're
equal.
All right, let's do it democratically. How many think they're the same? How many think this one's larger?
No, that's
No, it's
It
less.
makes it a whole different.
Now they say it's less.
Wait a
It's the
minute.
same.
Yeah, the bottom one's the larger.
Yeah.
I think the bottom is larger.
Because there's an extra digit.
Could we put a 0 here?
0 ain't no digit.
0 there.
Right.
So technically, if we put a 0 there, now what?
Equal.
They're the same.
Okay, well that combine with like a million zeros after that.
How about this one?
Top one is bigger.
The bottom.
Top one. Top one.
Stop. No, top one's
All right,
bigger.
by a show of hands, how many people think this one's bigger? All right, how many people think this one's bigger? One person. Let's do a rule. Go to the leftmost. Ones are the same. Zeros are the same. So to this point, they're both the same. 8s are the same. They're the same to this point. Oh, wait a minute. Over here, this is 3. This is 0. 3 is larger than 0. This one is larger.
So quite honestly, it doesn't matter if one of the numbers has more numbers than the other.
No, I can put a 1,000 zeros here. Does that change the value?
No, I'm just making sure.
Like even if you put zeros after that 3, it would still be the same.
Yeah, it's the same.
No matter how many zeros you put. You just flip what you did before.
Top one's bigger.
Top one.
How many people say the top one?
I don't know.
All right, let's check. 2s are the same. 1s are the same. 3s are the same. 7, 0. This one's larger.
Yep.
Top one.
Oh, no, it's the top one.
The top one,
Yeah, this one, you go to the left, this doesn't have a digit here, so this one's larger. How about this?
The bottom one is larger.
One.
Because of the place value.
Yeah. In the hundreds column, this has 0, this has 1, so this is larger than this.
The bottom one.
The bottom one is the bottom one.
Oh!
The bottom.
You can do that.
The bottom one. Could you put a 0 there?
Yeah, but
That
it's like
one.
that's a repeating, like,
It's not repeating.
Because he didn't put the lip.
the bottom.
Bottom.
Okay.
Did we figure out what one